Thank you. So as Liz said, I'm the Director for Sustainability and Energy. So my office, basically we deal with everything from the purchasing of energy to figuring out ways to reduce the energy and also to collect the energy on a monthly basis. We have basically about a total of 1,700, a little more than 1,700 utility bills that come in on a monthly basis and a quarterly basis that we have to account for and then be able to distribute over to finance through reporting so that they could basically charge out to the various buildings and departments within those buildings to pay for the energy. So the PowerPoint presentation I'm going to do, I utilize it a lot for when we do tours here at the university or when I'm presenting to students or anybody else and we go through the various buildings and look at different things within the university. So first off, people are always wondering, well, what is sustainability? And sustainability is utilizing the resources that we have today without compromising the ability for future generations to meet its own needs. So we're trying to utilize all the different resources we have, through building materials and energy and everything else, so that our grandkids and our grandkids' will have the same opportunities that we have and be able to, live the type of lifestyle that we live today. So, and the three pillars of sustainability is environmental, so humans living within the means of our natural resources, economic, the entity, so that we can operate in a sustainable manner consistently and produce an operating profit with using its resources responsibly and efficiently. Basically, for us, it's maintaining our budgets and keeping within the budgets that we have here at the university while utilizing the materials in a sustainable manner. And then social is society or social system has the ability to achieve social well-being. So the well-being of everyone here at the university, that's part of what we do. I mean, it's part of what's built into what we're building in the buildings that we build, the renovations that we do. We're here for the students and for the researchers, and we want to make sure that they, have an environment that for learning and for research. So one of the things that I do, like I said, I utilize this presentation to for when I have tours and student staffs, and this is just some of the things that I do. I do the overview, which we're basically going through right now with the PowerPoint presentation. We do a tour of our 2 solar farms. We tour the geothermal field in the business school, and then we tour the lead chemistry and biology and engineering building, which are 2 LEED Gold buildings, which I'm going to talk about a little later on. So energy and, we talk about sustainability. One part of sustainability is energy. Energy and sustainability, they go hand in hand. We're looking to be able to mitigate the climate change that's happening right now. We're looking to reduce our carbon footprint here at the university, and the president is supporting a reduction in our carbon footprint, along with he just put together a task force through academics that are looking at our carbon footprint and ways that we can reduce it to become carbon neutral. I don't know if you people have been reading newspapers, but the state of New Jersey is coming out with an energy master plan. It should be finalized by December. We'll see if that happens or not. But within there, they're looking to have the state of New Jersey of all its electric to be 50% carbon neutral by 2030, which isn't that far away, and then 100% carbon neutral by 2050. With that, when that happens, the university is going to have to look to that, and we're going to be following their guidelines and figure out ways that we're going to be reducing our carbon footprint here at the university, especially for electricity. So when we talk about the energy that we use at the university, we use a lot. We spend about $78 million a year for the energy here. That's for the electricity and natural gas here at the university to be able to heat the buildings, light the buildings, energy to do whatever research and what have you. This is only, and the $78 million doesn't include transportation. It's only for our buildings and for our facilities and and the grounds around us. So we're utilizing 549,571,000 kWh a year, and 41 million, a little over 41 million therms a year in natural gas. Now, as the university has been expanding, we have new buildings. Our energy overall has been going up by percentage points, but our energy intensity, the amount of energy that's used per square foot per building, has been going down, and at some point, some years, it's been neutral. So even though we've been expanding, we've been able to reduce the amount of energy. And the reason why we're able to do that, with the newer buildings that we're building, we're building to LEED Silver equivalent, and part of that is an energy reduction put in there. We actually do energy models on the new buildings that we build as compared to 90.1 2010. ASHRAE 90.1 2010, and we're about 15 to 20%, using 15 to 20% less energy than a standard building that's built with those standards. So each building, we're actually being able to show that we have a reduction in energy in the buildings we're building, and then newer buildings, older buildings, we're looking to do different things as we do major renovations. We're also putting the same standards in there also. So just some more numbers. This is how much we actually produce. About 30% of our own energy through the solar and through the cogeneration plants. At the moment, we are actually looking to upgrade both of our cogeneration plants that we have. The one on the Bush campus, going from 13 megawatts to 15 megawatts output, and then the one up in for RBHS up in Newark. That one will also be a 15 megawatt plant. The equipment and the plants themselves, we're going to see a reduction of about 8 million gallons of water per year per plant, and a 50% reduction in emissions compared to the emissions that are being produced right now at the two cogeneration plants. It's going to be about 18 months to build each of them around in that timeline. We will be shutting down the plants and then basically purchasing power and utilizing our boilers to take care of the heat load that we have coming out of the cogeneration plant. Just to give you a little background of what cogeneration is, we basically use natural gas to fire a jet engine. Jet engine spins, it turns a turbine that produces electricity. The byproduct is heat. We utilize that heat to make high temp hot water and steam that we utilize throughout the university for heating, for high temp hot water, for domestic water. We have loops on both the Bush and Livingston campus, and then up in RBHS in Newark, it takes care of the Newark RBHS campus, along with the university hospital. We provide power, electricity, high temp hot water, chilled water over to the university hospital up in Newark. And then energy, well, here's the reduction, actually. I went backwards, what we purchased, and this is actually what we reduced right here. And again, it's about 30% of our overall energy is produced here at the university. So, we're doing all these different things. We're utilizing cogeneration, and about 9 years ago, we decided that we wanted to make an impact utilizing solar energy. The state came up with a plan where they're going to have us give us 50% of the money to build a solar farm, and the university put up the other portion of that. It was a $10 million project. It's 7 acres of land. It's 7,996 panels. They're fixed mounted, facing south. They produce, again, I said, the 1.4 megawatts of solar. That's about 10% of the Livingston campus during peak demand. The way that we paid this off, the portion that we put in there, we paid it off through the solar and renewable energy credits. So for every megawatt hour of power that we produce through solar, we get a credit. It's basically a certificate, and the certificate is worth money. Utility companies, any utility company that supplies electricity in the state of New Jersey needs to have in their portfolio renewable energy. the way that they do that is they'll buy these certificates from us. When we first built the solar farm, they were about $675 an SREC. Over the years, they had dropped down to almost $70 an SREC. The legislature had to come in and expand the amount of renewable energy that the utility companies needed, and now it's been staying steady about $230 an SREC. And with that, we're able to actually pay this solar farm off. This is all paid for, done. We own the SRECs from now on. That's money that comes into the university that we could utilize for other things. They subsequently have changed this plan. It was for 15 years that you could go with a solar renewable energy credit, and they just reduced it down to 10 years. So that changes the plans of how we're going to look at solar energy here at the university. That's one of the factors of what we plan to do as far as solar in the future. This is what it looks like overhead. It's over by 6 Brew Circle. Interesting facts about this. When we built this, we were actually going to use stone throughout here to cover it up. The state of New Jersey came back and said if we put stone down, that they would consider that impervious, meaning rainwater couldn't get through, and we basically have to build a lake to take care of all the water that they said would be coming off this. So we left it as grass. And subsequently, from it being grass, it's become basically a preserve. We have deer, we have fox, we have coyote. There's animals nesting in there all over the place. And it's a pretty interesting thing to see in there. As far as the panels, people ask, well, do they get dirty? Well, we get enough rainfall that they stay pretty much clean all year round. We actually tested them out, and there's no real degradation. The one problem we do have is during rutting season, if we get bucks in there, they do have a tendency to rub up against the panels, and they popped up a couple of them here and there. But other than that, no real damage with those panels.
So they don't have a set lifespan?
The panels themselves, after 20 years, they start degrading. By about 30 years, they're about 80% of the power produced, but they still function. We have them guaranteed for 25 years that they have to produce the power that they were constructed at, both this and the solar canopies that I'm going to be talking about. So these are just some quick numbers. It was $10 million for the project. BPU put up 4.9, we put up 5.1, and we paid the thing off, like I said, through the SRECs. It's all paid off. I'm going to jump into geothermal, and then we'll go back to the solar canopies. So one of the other projects that we decided to do, we started looking at geothermal. We actually, when we were looking at geothermal, which is utilizing the grounds as a heat source and a heat sink for electricity. For heating and cooling. We're looking to actually do all of Livingston campus. We were thinking that we could be able to do that during the period of time when they were doing the construction. But things were just moving along too quickly for us to be able to do that. What we were able to do was we looked at the business school, and that we concentrated on doing geothermal for that. So we have 321 wells. They're 500 feet deep in the ground between Levin and the student center, that big quad area. So there's a 6-inch diameter hole, a 2-inch diameter pipe goes in, it comes out, they get interconnected all the way through, and they go back to, like I said, there's 321 of these wells that come up, interconnected, and go over to the business school. And within the business school, we have what are called chiller heaters. So basically, during the summertime, as we're producing chilled water to cool the building, on the condenser side, where we're compressing the refrigerant to make the coolant, we're running that through the wells in the ground. So we have this hot water goes into the ground and gets cooled down. Now the ground itself is 55 degrees all year round. So we dump the hot water in the ground, it takes the heat out, goes back out, and we utilize that to keep cooling the building. During the wintertime, we do the opposite. We actually drop the chill water, which is at 42 degrees, into the ground to heat up because, again, the temperature is 55 degrees, and we utilize the condenser side to heat the building. And in reality, if it's balances out properly, we actually can do simultaneous heating and cooling just within the building and never touch the wells, the geothermal wells. They get heat and cool pretty much by itself. And it's about 30% more efficient than if we did it with a boiler, your standard boiler and chillers within the building. And it has worked out very well within the building. I'm very happy with the way that came out. These are just some of the pictures as we're digging the wells. We had 3 of these well diggers out there digging these wells 500 feet deep. So that's the business school. And I'm going to go back now to the solar canopies. It's over 32 acres of parking on Livingston campus. It's 28 acres of solar over these 32 acres of parking. There's 30,000 panels out there. We have 16 inverters. I guess I should tell you about how solar works. So the sun shines down onto the panel and produces DC electric, just like you have in a battery. So we take all these panels and combine the voltages from all these different panels, and it combines up to 400 volts. We take that 400 volts DC and we put it into an inverter. Now what the inverter does, it converts it from AC from the battery, from DC from the battery to AC like you plug into the wall. So we convert it over to AC electricity. Now it's alternating current just like you plug into the wall. And then we boost that up to 13,000 volts because that's what we have for power lines within the university. So just so you have an understanding, we purchase energy from utility companies, electricity. It goes to our substations. Once it goes into the substation, Bush and Livingston and up in Newark, it becomes ours, and we own all the power lines in between. And we have a whole department that does all the high voltage electricity. And again, on the hot water side and all the piping that's in the ground, moving water around, there's a whole department that takes care of all that, the infrastructure underneath. And there's about 28 miles of piping that's under the ground right now throughout the university. So we're making the electricity, and we're producing a little over 8 megawatts of solar power. With this combined with the other 1.4 megawatts, during peak season, we produce about 63% of the power for the Livingston campus. And during the wintertime, when we're not running all the chillers and what have you, we could actually power 100% of the campus and actually have a little bit of power that will go over to the Bush campus during the wintertime. And these are just some of the, when we did the solar canopy project, instead of outright buying it, we did a design build on the solar canopies themselves to build that. And then we went with a lease agreement. We went out to finance companies and got a lease agreement. And through the lease agreement, it's actually a 15-year lease. And Rutgers keeps the savings and the SRECs. And by doing that, basically, we take the SRECs, the money we get from the SRECs, and that's how we pay the lease every year. And we're cash positive every year with that lease, so that there's actually money left over to spend on other things within the university. And these are just the opportunities that the finance company, they're able to receive a 30% tax grant, 5-year accelerated depreciation on the solar panels. And again, we got to maintain the SRECs and the energy savings from the solar canopies themselves. And this is just an overhead view of the whole thing. So you can see we have the solar farm, solar canopies on the parking lots. You can see the solar farm in the background. This over here is where we have all the geothermal, and that's the business school that's heat and cooled using the geothermal energy. So along the way, one of the first things you want to do, before we even do alternative energy, we want to look at ways that we can conserve energy, ways that we can reduce energy. And we've been doing that all along. We've been looking at the high tempo water lines and replacing them. I don't know if you've driven around the campus during the wintertime, and you'll see where steam's rising up from the ground or from one of our vents throughout one of the campuses. What that is, it's not that a pipe is broken and steam's being ridden out. What's happening is the insulation on our high tempo water lines have broken down, the older piping, and groundwater is reaching that, and that's where the steam comes from that rises up. So we've been replacing them over the years, and we've been able to get significant savings through that. Another project we went through the university and realized that we had a lot of motors that were just a standard type efficiency motor, and that we could replace them with a premium efficiency motor with a really good payback. So we went through the university, replaced the motors and transformers, and we were able to save, again, a significant amount of money. It was like $300,000 a year in energy savings by doing that. Along with that, we did various lighting projects throughout the university using PCG's direct install program and New Jersey's Clean Energy's direct install program. We're going to be utilizing that again because at the time that we did this, we went through and reduced the fluorescent power from, it used to be 42 watts down to 28 watts, and now we're going through and going to replace it with LED. Any new building that we're doing, we're putting LED lighting in, so it's almost automatic. But there's significant savings, and there's really good programs right now to be able to put in LED lighting in the existing buildings that we're going to start putting together packages to be able to do that. So we're doing all these different things with energy. Now I want to start talking about LEED, about sustainability and what we do here at the university. So every building that we build it to a LEED Silver equivalent. That's from the U.S. Green Building Council. It gives us a benchmark to make sure that our buildings are being built sustainably. Our construction standards and our design standards are written so that it's almost automatic that happens, that a building is built to a LEED Silver equivalent. One of the things we do right from the very beginning is integrated design. Everybody is at the table, everybody from maintenance, from design, from utilities, from public safety, the occupants of the building, users of the building, are all sitting in a room deciding what's the best way to build this building, and that's basically what integrated design is. And it's actually part of when you're building something utilizing LEED that you're going to do. And we do that here at the university. Along with that, if we decide that we're going to go for the plaque, then if the end user wants to go for the plaque, we'll actually go for a designation through the U.S. Green Building Council. And just recently, 2 buildings, the chemistry and biology building was just rated a LEED Gold building, and the engineering school was rated LEED. So, I do a tour with the students so that they go through and see the various things that we do as far as LEED and some of the points. So some of the areas they look at is development density. Where is this at? Are we close to public transportation, banking, dining? Are there charging stations nearby? Do we have bike racks? Can people come and ride their bikes to work? Do we have a place for them to be able to shower if they're utilizing bicycling? Water efficiency, we have rain gardens, bioswales. If you go outside this is the new chemistry biology building, you can see all the different features up in the front of how we're utilizing to filter the water before it goes into the streams and then into the Raritan River. Energy and atmosphere, we're looking at the CO2, sensing the CO2 within the building so we can designate the exact amount of outside air that we want to bring in. Outside air, you need to be able to condition it to whatever the space is going to be. If it's a hot, humid day outside, we're cooling it down first to remove the humidity, and then for cooling the building at the same time, we may have to heat the air up a little bit for various areas so that they're comfortable once we remove that humidity. Some of the other things are innovative design. We have a green green cleaning within the buildings. Dave DeHart had spoken about all the green cleaning that we do. We're one of the top universities as far as that is green cleaning, and as far as our waste and recycling, we're very efficient with that. along with even, the carpeting we use is recycled carpeting. The way that it works is when this carpeting gets ripped up, it's going to go back to the manufacturer. The furniture that we utilize, we're looking for sustainable furniture and, and interior. The paints that we're using are low VOC paints. So we're trying to utilize materials that are sustainable and are health conscious at the same time.
Mike, for people who may not know, could you just explain how, when you're designing the building to LEED standards and you're trying to get that gold LEED certification, all of those things get you points, right?
Right.
So if you could just explain that, because some of these people may not be in construction all day.
Okay. Yeah, so we like I said, we follow the LEED standards, and it's basically points, and it starts out with how the building is, where the building is situated at, how it's built, the direction it's at, and then we'll get points for, if we're close, like I said, to things like banking and dining and things like that. And then they look at the interior of the building, whether or not we're using for energy and atmosphere, are we using low VOC paints? Is the off-gassing within the building, mainly you're concerned about that you want to make sure that it's a healthy building for people to be able to go into. Then there's also the energy portion. We want to be able to reduce the amount of energy we're using. It takes into consideration recycling. Not only, the recycling that we do on a daily basis, we have to, show that what we're doing with that, but also the materials when we're building the building itself, construction. We want to make sure that all the materials that can be recycled that are coming off site as we're building can be recycled or maybe reused. And then other things like the innovative design, being able to with the green cleaning and education outreach of what we're doing as far as the buildings and commissioning and things like that. One of the areas, like I said, is material and resources. I was talking about the waste. So when we built the chemistry and biology building, we were able to divert over 97% of the waste was diverted from landfills. So it was recycled and various waste material was brought out. So it's a fairly high number. 11.54% of the building material was recycled material during construction. 23% of the materials came from within a 500-mile radius. You want to try to be able to use materials within a locally sourced area so that you're taking care of the local economy, plus the idea of being able to transport those pieces of material to your job site. And we also, wood that was on the project was obtained from the Forest Stewardship Council. So we know specifically the chain of command, chain of custody of where that material came from and that it's readily a renewable material. So in the indoor environmental, again, part of the occupancy IQ management plan was put in place. We actually aired out the building so that all the off gases of different materials were eliminated from the building so that it's a safe environment from day one when people come in. And within the year, we'll be doing a thermal comfort survey to ensure that the building is meeting the needs of the occupants within the building. Again, we talked about this, the region priority, where the engineering school and the biology and chemistry building, we have an average of 387 bus transportation stops per day, meaning that there's always a bus there for people to move people around within a quarter mile of the entrance of the buildings. And then this is Richard Weeks Hall. This is another gold building, the engineering building. Again, we're going through basically the same thing with the bicycle storage, changing rooms, being able to, we're planning to put charging stations in. They haven't been put in yet for alternative vehicles. We use indigenous plants. We're used for planting. And we look at low-mow type of plants, along with things that don't need to be irrigated as much. Within the buildings, we use low flow type of fixtures throughout for the sinks and toilets and everything else. Again, minimizing irrigation and other different ways to reduce the reduction of water use. And we also, speaking of water reduction, we've been doing various water reclamation projects. Tetalonis did a really great project up in RBHS Newark cogeneration plant. We're recovering millions of gallons of water a day that was just going down the drain because of one of the processes we have. And now we're reutilizing that water and utilizing it for our chill water cooling towers, and along with other systems within there. So it's a really great project. And I think it was in one of the articles that.
I think they practically eliminated their water bill, didn't they?
Yeah, just about. Yeah, for those processes. Again, in the engineering, building, energy, and atmosphere, we had an 18% reduction in energy compared to a standard building, which is pretty phenomenal. And again, the building was commissioned using enhanced commissioning, so we went a step further on ensuring that all the pieces of equipment work properly, the air conditioning works, the controls within the building were working optimized to best utilize within the building. Again, 75% of the waste in this building was diverted. 10% of the building construction was recycled materials, and regional materials and certified wood, again, was used for this building. I talked about the indoor environmental air quality. This right here, really, this is the best website. If you ever want to find out what you can do, what monies are available to be able to reduce the energy, here at the university or, within your house too, you go to that website, you pick on your state, and it'll tell you specifically what programs are out there that you could use to fund projects within here or within your own house. And with that, that's pretty much it. I mean, if there's any questions about anything. I know I threw a lot at you real quick. Yeah.
I have a question. How did you identify the water waste at the cogen? Like, what was the process of identifying this waste and then actually devising a system to capture it?
Well, there's these pumps, seals on these pumps that needs constant water to be able to maintain the water seals. And that water was basically a once-through system. So the water goes through and it goes down the drain. So we know that we're just dumping water away that could be utilized for other things.
Do you do investigations? Like, how did that come to you, that waste? Because you're not in Newark, right? You're here.
Yeah. So there are people up at the plant, and Ted's up at the plant. I go out there up to the plant. I don't just sit at my desk. I actually do go out to the field. So Ted brought it to my attention. He said, "Hey, we're putting this water once through the water seals. You think we could do something for reclamation?" I said, "Yeah, look into it. There's probably a way." We had done something similar years ago. We were going to do something over Waxman. It never came through. I kind of, told, and he kind of knew what we were doing there. So he brought it up there, and it works out. I mean, we were able to utilize that water. It's millions of gallons a day that we're reusing. So it's a really great project. Unfortunately, the problem with water right now is it's so cheap that it's hard to get a really good payback on water reclamation. So you have to watch what you're doing with that. So we'll look at other things as far as water reduction. I mean, it's not like with electricity or natural gas, where we know that if we do things more efficient, we're going to get a very good payback, and it's going to be a couple of years. It's a much longer payback on water right now. Yeah.
Are those two buildings that are now gold certified, they are our first two gold certified buildings?
Yes. Yes, they are. Yep. We do have the couple of buildings on College Avenue that are LEED Silver and LEED accredited, but this is the first two LEED Gold buildings. And to have a chemistry and biology building that's LEED Gold is pretty phenomenal, because of the fact that they are such a high energy usage type building. I mean, when you have a fume hoods within a building, I mean, that's once through. The air is coming in and going right out. So we're actually, we spend money to heat and cool that air and remove the humidity. It goes into the space and it's just being diverted right out. So there's different mechanisms that we're using to reduce that from happening, and along with other things that we did within the building to make it much more energy efficient. And then all the other things that we did as far as materials. And the thing that's amazing about it, we're able to do LEED Gold with things that come right off the shelf. Whereas, 10 to 15 years ago, it would have been very difficult to try to achieve that. Yeah.
Quick question, Mike, regarding New Jersey and their incentive programs, retro commissioning older buildings to get them back up to snuff. Since things degrade, there's technology that can be changed. Is there money that New Jersey provides building owners to do that?
There is money available to put in more efficient equipment and also, more efficient lighting and what have you. It's not directly tied to commissioning, but utilizing that money, we can go through, they'll do an audit, we can do an energy audit of a building. We're allowed to do up to about $100,000 a year in energy audits. We can come through, do an energy audit, see what equipment's not efficient, and build in commissioning into that so that we can do the retro commissioning at the same time that we're utilizing these other funds. And it's fairly easy to do. We just have to, maintain a certain payback. And it's a fairly high payback number that they use, so years.
Especially laboratory spaces, right? Because there's so much conditioned air.
Yeah, yep. Yeah, back and then you, Gary.
The piping, you mentioned about the insulation breaking down for high tip line. So when you do the geothermal system, is that insulation subject to the same type of wear? Or
Well, with geothermal, we actually don't insulate the pipe. We want it to be able to, the heat or the cooling, we want to have a good transfer. We actually, the pipes themselves are grouted. We have grouting around it so that the transfer is very good between it. And because we have shale, it's a very good heat transfer rate that we have.
so as we transition to systems like that, there would be no need for digging up the ground everywhere after a certain period of time if we were more geothermal, if there were more systems?
If there were more geothermal systems, they're supposed to last 50 years. The way that we have the system set up, that if we did, say, somewhere along the line, we sprung a leak in one of the wells, we could literally valve that well off, and it's not really going to affect the overall efficiency of what we're doing. And geothermal is just one way of us to be able to heat and cool. And I think you're going to see more of it in the future on newer buildings. Whether we do it here, we're going to have to wait and see. There's a lot of other things that we can be doing right now. We're going to look at thermal storage as one way. We're going to look at energy storage, for electricity. Is that a way for us to, better utilize the energy that we have here at the university? There's various factors, and we're looking into all that stuff right now.
The state requirement, is that a requirement or a mandate that we 50% carbon footprint by 2030?
It will be a mandate from,
Mandate.
yeah.
And do we actually have a plan to get to that point? for
Well,
Rutgers?
they need to finalize their plan. And within that plan, they're going to have measures for us to be able to follow to get there. Because one of the things that the state is doing right now is we're going to build wind farms out on the ocean. And that's where a significant amount of this energy is going to come from. Nuclear, I don't know how nuclear is going to play into this, because it's totally carbon neutral, but it has other factors that are
Yes, but what's Rutgers' piece of that? Like, how much of the footprint are we creating within the state of New Jersey now? And are we expected to be 50% of our own footprint versus what we are right now? I mean, are we
As far as electric, yeah, we will more than likely be mandated to be 50%.
Everybody has to do their part.
Yes, yep. And right now, there's, on the academic side, they're looking to see what our carbon footprint is at this moment. And then from that, we're going to start looking at ways that we can mitigate that. There's plenty of things we can do. I mean, right off the bat, the amount of energy efficiency projects that we could do, we could knock off at least 15% of our energy, down the road. I mean, it's going to cost some money to do, and that's what we need to see with the state, how they're going to work with us to be able to.
I mean, the new turbines that we're putting in both Bushy and RVHS, is that gonna bring us within 50% of the footprint for what they're producing, or are they gonna be out of date by then?
Well, right now, they're going to be a 50% reduction in the energy emissions we have right now. So yes, we'll meet the 50% reduction of that piece of that. Yep. Yeah.
With the changes in the state with solar power and SREC returns and such, do you have any solar projects planned for the near future or not?
We've been looking at that, and because of what's going to happen with the state of New Jersey and what they're going to be requiring, it looks more and more like we're going to rely on the utility companies to build out the solar, or we're going to look at, one of the things we're looking at is there's private companies that are building solar farms that we could purchase the power from. And does it make sense for us to do that? We have to see what the cost is going to be, if it makes sense to us. Because when you build a solar farm, you have to maintain it also. And so there's other costs that are added to it that we're looking at, that if the utility companies are building it, they're going to be able to do it on much cheaper than us trying to do smaller pieces here and there. And that'd be a way to buy the solar that we're going to need. And it's something we're looking at. We're waiting, like I said, we're waiting for the master plan to be finalized so we can see what we're going to have to do.
Anyone else? Yes.
Yeah, Mo.
How are we going to replace the power plant at College Avenue?
Right now, we are looking at, there's a couple things going on. With the expansion that we're planning to do on College Avenue, we're more than likely going to build another cogeneration plant over there to be able to handle that.
Is that going to be like public-private partnership as well?
Don't know yet. I can't answer that. I don't know. Don't know what direction that's going to go. We're looking at all different scenarios with that, and we haven't gone down that road too far yet. We're looking at private partnership stuff. We'll see. We'll see what happens. Chelsea, did you have a question?
Oh, yeah, you mentioned the LED replacement. I was wondering, how do we dispose of existing fluorescent light bulbs?
Oh, they're recycled through waste. The waste management company that we use, they take them away and they're dealt with. Yeah, and speaking of hazardous waste, do you know that the solar panels themselves are actually hazardous waste when they're over and done with? And we actually have a contract with the solar company that they'll take them away and reutilize them, so that we don't have to worry about that hazardous waste in the end of life with the panels.
At no cost?
No cost. It's already part of the contract that we paid. Yeah.
Why are they considered hazardous waste?
Because they have hazardous materials in them.
Like what?
They're silicon based. There's other different factors within there. I don't know specifically, but I do know that there is. I can't remember offhand, but I have the cut sheets that show it.
Anyone else? Very good. Mike, thank you very much.
You're welcome. Pleasure. Thanks.